Okay, so here's our lesson on logarithms. Now remember, logarithms always equal an exponent. And so what exponent on 3 gives me 81? Well, the chart, if you don't remember the chart I've got on my wall, it's attached to the study tools. And it says that the exponent on 3 that gives me 81 right here is 4. So the log 3 of 81 is 4. Now this is a little different. This has a 1 over 32. And if you remember back from high school, a negative exponent just means flipped. So I can say the log 2 of 32, and looking at your chart, if you don't have it with you, it's in study tools. The log 2 of 32, right there, the log 2 of 32 would be 5. Would be 5. So to make it 1 over 32, the exponent would be negative 5. Remember, a 1 over has a negative exponent, unless they're both 1 over. The exponent on 5 that gives you 1, what exponent do I have to put up here on a 5 so that my answer is 1? If you look back on your sheet, you'll see that 5 to the 0 power equals 1. So the exponent on 5 that gives you 1 is 0. How do you handle a 1 over? Just use a negative exponent. This is a symbol that we know, the square root, but we don't think of that as an exponent. But the square root is the same as saying to the 1/2 power. On your scientific calculator, if you type in 49 raised to the 0.5 power, you'll get 7. So on this problem, what exponent on 7 gives you 7 to the 1/2? Well, the answer is 1/2. I should say equals, is 1/2. You can also look at it and we said that log base and a base cancel, so it's 1/2. The important thing to remember is that the square root means raised to the 1/2 power. Another thing about logarithms, when you don't see a base, it's understood to be 10. So this says, what exponent on 10 gives me, now you might remember that 0.01 is 1/100th. Well, the exponent on 10 that gives me plain 100 is 2. So what exponent would give me 1 over 100? Negative 2. The fractional exponent means the root. The negative exponent means flip it, reciprocate it. Now, there is a number called e, which is like pi. It's one of those numbers we can't write easily. But this says, what exponent on e gives me e to the 3? What exponent on e gives me e to the 3? Well, the obvious answer is 3. Or you could remember what we learned the other day about a log base and a base cancel, so the answer is 3. Looking at the chart, which is in study tools or on the board behind me, 5 to the 2 power equals 25. So the log 5 of 25 would be 2. But because that's 1/5, which is a reciprocal, it's going to be negative 2. All right, who remembers what the base is when you don't see one? That's right, it's 10. So this says, what exponent on 10 gives me 1,000? Well, you may remember that 1,000 is 10 to the 3rd. So what exponent on 10 gives me 1,000? 3. Logarithms are exponents, and bases and log bases cancel. Logarithms are exponents. Bases and log bases cancel. Let's use that idea to solve some logarithmic equations. I have log 2 of 64 equals 4 minus 3x. Now, there are several ways to do this, but let's use the inverse property of logarithms and exponents. And since I have a log 2, I'm just going to do a base 2, and that gives me 64 equals 2 to the 4 minus 3x. Now, if you look on your sheet, 64 is the same as 2 to the 6th. And if I cancel my bases, I have 6 equals 4 minus 3x, or x equals negative 2/3. Again, my idea is to use the inverse property of logarithms and exponents. If I have a log base 5x plus 2, I can use a base of 5x plus 2. And they cancel. A base of 5x plus 2 on both sides, and they cancel. Now, think of it this way. You cancel out the log and pull that over here as the base. 243, if you look on your chart, 243 is 3 to the 5th power. And since equal bases have equal exponents, I can cancel the exponents as long as everything's positive. You get 5x plus 2, so x is 1/5. Using the inverse property of logarithms and exponents, if I have a base of 1/3, I can just use a power of 1/3, and I get x minus 2. Let's redo that. Let's do that a little differently. Let's flip that and make that, say, the log 3 of x minus 2 equals positive 2. Because remember, when you reciprocate your base, you change the sign in your exponent. Now, using a base of 3, the log 3 cancels, and I get a base of 3 over here. X minus 2 equals 9. So x equals 11. Since I have a reciprocal, I can make that say plane 8 and change the sign on my exponent. Remember, logarithms equal exponents. So change the sign on the exponent means changing the sign on that thing. Okay, what's the inverse of a log base? A base. And if I do a base of 2, that's going to cancel, and I'm going to have 8 equals 2 to the negative 2x minus 9 power. And rewriting 8, using your sheet I gave you, is 2 to the 3rd. Well, when I cancel out the bases, I have 3 equals negative 2x minus 9. So x is negative 6. Once again, the idea up here was that the inverse of a logarithm is a base. The inverse of a base is a logarithm. Now, we've been solving these base problems in the classroom where we have things like 27 to the x equals 81, where we have reduced these to common bases. But what about something like this where they don't have a common base? 2 and 5 do not have a common base. Well, there is an answer, but it's a ugly decimal thing. We call it irrational. You can't write it as a fraction. And we're going to solve a base to a power by doing a log base on both sides. Well, of course, the log base and the base cancel, and I have x. And over here, I have log 2 of 5. And that's it. Let's do that again. Let's do all that again. I'm going to solve a base exponential that doesn't have a common base by doing a log of that base. And I'm going to say the log 2 cancels, and on the right I have a log 2 of 5. I did a log 2 on both sides, and over here it canceled, and I just had the x, and over here I had log 2 of 5. I'm going to be able to do the same thing in this one. Once I isolate that exponential, I'm going to say 3 to the x power equals 13. Remember, I added 5 to both sides. And I'm going to undo a base 3 with a log 3, log base 3, and that's going to cancel and give me x, and that's going to have log 3 of 13. That doesn't look like a 3. I'll make that a 13. Once again, if I can get the exponential by itself, I'm going to have 5 to the x minus 3. How am I going to get it by itself? Dividing by 2 equals 4. And since 5 and 4 don't have a common base, I can't do it like we did in class. I'm going to have to use a logarithm. I'm going to log base 5 to both sides. And here that cancels, and I get x minus 3. And over here, I have log base 5 of 4. Not quite finished yet. One more step I have to take. Add 3 to both sides. And I can't add logarithms and numbers together, so I have x equals log base 5 of 4 plus 3. Once again, to solve a base, I'm going to use a logarithm, but I have to get the base by itself by multiplying both sides by 3. I have 7 to the 5x power equals 6. How do we do an undo a base? We undo a base with a log. I'm going to log 7. That's going to cancel out and give me 5x. When I log 7 here, there is no common base, so log 7 of 6. And dividing both sides by 5 over 5, or 1/5 log 7. Same operation, same answers, just look a little different. All right, so let's look at some things we can do with logarithms. Since logarithms are exponents, if you're multiplying the bases, you can add the logarithms. Inversely, if you're adding the logarithms, or conversely, you can multiply the bases. Same thing, if you're subtracting logarithms, you can divide bases. And finally, when you have a number to a power, an exponent to a power, you simply multiply the exponent. So a number in front can become a coefficient can become an exponent. A coefficient can become an exponent. So let's look at how we're going to simplify this expression. And I kind of gave you a heads up here. Multiplying becomes exponents, then adding becomes multiplying. Multiplying becomes exponents. Multiplying becomes exponents. I took each of these things that was times the log and turned it into an exponent. And finally, adding or subtracting becomes multiplying. Adding or subtracting becomes multiplying or dividing. I have x to the negative 2 times x minus 1 to the 1/2 times x plus 5. Each coefficient as an exponent, and each sum or different as a product quotient. I have a coefficient I'm going to write as an exponent. I have a coefficient I'm going to write as an exponent. I have a coefficient I'm going to write as an exponent. There's other way I could do that, but I'm going to skip that. I have coefficient, don't have a coefficient here. And then I'm going to write addition as multiplication and subtraction as division. I'm going to write addition as multiplication and subtraction as division. So I took this subtraction and put it on the bottom. I put the addition and put those on top. The positive ones go on top, the negative ones go on the bottom. Let's try that with real numbers. Okay, coefficients become exponents. I don't have any coefficients. Addition becomes multiplication, subtraction becomes division. So this whole thing simplifies up to log 3 of 36 over 28 times 63. Make sure you see why the 36 and 63 are on top and the 28's on bottom. If you get your calculator out, you can simplify that. I'm old-fashioned, so I'm going to cancel. Let's see, a cancel a 4 leaves me a 9, and a 4 leaves me a 7. Cancel a 7 leaves me a 1, and a 7 leaves me a 9, and that is 81. You're probably going to grab your calculator and do this, but you're going to get 81. So, looking back on our sheet, this says the exponent on 3 that gives me 81, and I want an integer. The exponent on 3 that gives me 81. The exponent on 3 that gives me 81. Right there in the middle, the exponent on 3 that gives me 81 is 4. Whoops, skipped it. 4. All right. Coefficients become exponents. Addition becomes multiplication, subtraction becomes division. This is going to say log 5 of 50 times 15 over 36 to the 1/2 power. Now, what do you remember about a 1/2 power? That's right, it means the square root. Now, I expect you'll probably get your calculator out to figure all this, but I'm lazy. I'm just going to cancel stuff. Cancel a 2, which leaves me a 3, and cancel a 2, which leaves me a 25. Cancel a 3, which leaves me a 1, and a 3, which leaves me a 5. So that cleans out to be log 5 of 125. And if you look on your sheet, the exponent on 5 that gives you 125 is 3. On your test, I'm going to want a number. I'm going to want a number. On your test, I'm going to ask you for this and this. I'm going to ask you for this and this. Now, this next one's a little more complicated. It's got 4 terms, and it's not going to be a whole number. It's going to be a fraction, but we can still work it. Let's see. Coefficients become exponents. Coefficients become exponents. Multiplication or addition becomes multiplication. Subtraction becomes division. Now, you're going to get a fraction or a decimal if you just type that into your calculator, and you're going to have to find some way to turn that into a fraction. Remember that 5 squared is 25. And I'm going to do it the old school way. I'm going to cancel a 3 and a 3 and get a 10. I'm going to cancel a 5 and a 5 and get a 5 and a 4. And I'm going to cancel a 5 and a 5 and get a 1 and a 2. And so I'm going to have the log 2 of 1/8. Now, the log 2 of 8 is 3, so the log 2 of 1/8 is -3. Remember to reciprocate in a logarithm, not the exponent, but to reciprocate the others, you change the sign of the exponent. All right. Let's use our definition of logarithms to solve some equations here. Coefficients become exponents. Adding becomes multiplying. Adding became multiplying. And so since I have log 3 of both sides, I can cancel that and get 2x plus 6 equals 3x. So x equals 6. Coefficients become exponents. Adding and subtracting become multiplying and dividing. So this becomes log 3 of 7x plus 3 divided by x minus 1 equals 2. Why is it divided by? Because it said not plus, but subtraction. Now, I don't have a log to cancel on both sides, so I'm going to have to use a base of 3, and that's going to give me 7x plus 3 over x minus 1 equals a base of 3 squared, which is 9. Remember, when you cancel the log, you get a base on the other side. So, cross multiplying, 9x minus 1 equals 7x plus 3, 2x equals 4, x equals 2. You're really supposed to go back and make sure that none of these arguments are negative, because you can't have a negative logarithm, but I've made the problem so that they're not. All right. Coefficients become exponents. Addition and subtraction becomes multiplying and dividing. So that's going to be a 1/2 power. And I have log 5 of 2x plus 4 times 4. Make sure you see that that's a 4 equals 2. I don't have a log on both sides, so I can't cancel. I'm going to have to use a base 5. Use a base 5. That cancels. Use a base 5 over here. Gives me 25. 8x equals 9. 9/8. When we simplify logarithms, coefficients become exponents. Subtraction becomes division. Now, this problem we had at the top, we had a log on both sides, so I just canceled them. Right here, I had a log on both sides, so I just canceled the logs. None of these others have had a log on both sides, so I've had to use my base to cancel a power. Use my base to cancel a power. Log base 2, I'm going to use a base 2, and that's going to cancel. Make sure you see where that 9 came from. If I use a base 2 here, I'm going to have 8 over 1. Cross multiplying. 3x plus 1 equals 72. X is 71/3. Let's look at your top 10. Convert this to an exponent. Okay, we're going to knock the log off, and I'm going to get w to the x equals 3. I'm going to put the log on. T equals 4. Put the log on, and they're going to swap again. Let's use our definition of logarithms to solve the equation. Coefficients become exponents. Addition becomes multiplication. To undo a log base 7, I do a power of 7. which is 49. So 9x minus 36 equals 49. 9x equals 85. X is, that doesn't clean up nicely, 85/9. When simplifying logarithms, coefficients become exponents, and 1/2 power means square root, and subtraction becomes division. And to undo a log, I use a base. And 8 to the 1 power is 8. Cross multiplying, x plus 2 equals 40. X is 38. Okay, here are two exponentials. We have to get the exponential by itself. We have to get the exponential by itself. We undo a base 5 with a log 5. And here it cancels, and I have x equals log 5 of 7. Make sure you see where I got that 7. I have to get the exponential by itself. We undo a base of 8 with a log of 8. That cancels, and I have x plus 5 equals log 8 of 6. X equals log 8 of 6 minus 5. All right. We're going to simplify to a single logarithm and then to an integer. We're going to simplify to a single logarithm and then an integer. And let's see what we remember. Coefficients become exponents. Addition becomes multiplication. So that's going to become a 2. That's going to say times, and that's going to say divided by. That's going to say log 2 of 40 times 6 squared over 45. 6 squared over 45, which is log 2 of 40 times 36 over 45. Grab your calculator. I'm going to be lazy. Cancel a 5. That gives me a 4 and a 9. Cancel a 9. That gives me a 1 and a 4. So that becomes log 2 of 16. And if you look on your exponent sheet, the log 2 of 16, the exponent on 2 that gives you 16 is 4. Remember, I'm going to ask for both of those. And here we go. The last question. Now, don't worry about the stuff at the bottom. I want you to write a sentence describing that using this format. The exponent on, and what is my base here? K, that gives 15 is 3. The exponent on K that gives 15 is 3. That's how I'm going to phrase that on your homework and on your test. This has been a long lesson. It's been 30 minutes. I know this is a hard one, and this is something we would have done the first day after a test when we didn't have a top 10 to do. And I'm sorry it's taken so long, and I really hate that I'm not being able to see you and help you and see the question in your eye and know that you didn't get this one so I can go back and do it again. But do the best you can and send me a text or an email if you get in trouble. Thanks.